Here we go, my party people. Welcome in, and also happy Tuesday for those of you who are here live. Welcome into our class on Laws of Exponents. Cue the lightning and thunder, because for most of us here, Laws of Exponents might not be the most recognizable thing in terms of what to do automatically. But before we get started, I want to first make sure that you understand, or at least recognize, what I'm talking about. My party people, have you ever seen a practice problem on the ASVAB where maybe perhaps you saw something to the effect of x cubed multiplied by x to the power of 4? Anybody ever seen something like that? Oh yeah. Have you taken a practice test of the real deal? You've definitely seen something like that on the math knowledge section. Let's talk about something like this. How about having a fraction where we have y to the power of 7 divided by something like y to the power of 3? Nina solved something like that today? Right on. Did Risa hate those numbers? Yeah, those numbers be scary. But I got your back. I'm going to guide you along every step of the way. Because in today's class, we're not just going to be focusing on multiplying or dividing. We want to work our way up to the point where we can do problems that include both and more in the same problem. So I want you guys to be able to work up to the point where you can do something like x cubed multiplied by y squared divided by x to the power of 10 times y to the power of 3. I want you to be able to handle 2 of those rules at the same time, maybe even 3. My party people, do you understand that scope and sequence that we're going to be going through today? Learning the basic fundamental ideas and then practicing to the point where we can do those complicated problems. Hey, yes, it is, Michelle. I'm glad you're here. It's going to be a very interesting class. Right on. So let me go ahead and zoom on out. So go ahead and understand. We're going to review each of these laws. Then we're going to practice each type. But my surprise, because we're doing math knowledge today, we're going to practice immediately by being timed. I have about 22 questions that we can get through today. More if needed if we get through them quickly. But I'm going to make sure that we have the time and the space to give ourselves to make the progress. So here we go, my party people. Here are our main notes. Obviously an improvement from yesterday if you were here with that little mishap. So thank y'all for being patient. But let's go ahead and get into it, everybody. Laws of exponents. We have 4 things that we want to make sure we understand. Number 1, product of powers. Everybody, product of powers is essentially, right over here, multiplication. So feel free to take a second, just write this first one, because here's what I'm going to do, everybody. We're going to go over this first one. Then I'm going to show you some examples in this empty space over here. And then we'll move on to quotient and all this stuff over here. So again, nice and slow, just concern yourself with writing this first, and then type "got it" in the chat box. So again, the product of powers with the same variables. So again, when you're multiplying powers, you will add the exponents. So again, just write that one message down and then type "got it" when you got it. Right on, right on. All right, let's go ahead and zoom in and really understand how this works, because it's one thing to know what to do, and it's another thing to understand why you're actually doing it. So let's go ahead and take a look at this first example. Example 1. Let's go ahead and say we have x to the power of 2 multiplied by x to the power of 4. My party people, given what I told you, when you're multiplying, so product, when you're multiplying powers, this is a power, this is a power because it has an exponent. We say that we're going to add the exponents. So if I do that, everybody, technically, the exponent here is 2. The exponent there is 4. I think we have eyes. So if I add those exponents, 2 plus 4, I know, hard math. Yeah, that's going to be 6. And so the way that you'll write that is going to be x to the power of 6. So my party people, is that understandable? When you are multiplying when you're multiplying powers, just add those exponents. All right, good. So it looks like most of us are saying yes, but I got a follow-up question. And this is where things really start to reveal themselves in terms of confidence and knowing what to do and trusting yourself. Who here knows why you're supposed to add the exponents? Not just that you know you're supposed to add them, who here knows exactly why you're adding them? Oh man, some crickets. Combining like terms, you're multiplying, you're trying to find the product because you're multiplying, same variables. I see, okay, you're talking about why you're able to, but my party people, let me get into the nitty gritty with you. And I promise you, when I show you how this makes sense, you'll be like, oh, okay, yeah, that makes sense. So watch this. Everybody, help me out. First of all, let's talk about this. What does an exponent actually mean? So if I'm looking at this 2 right over here, x to the power of 2, what does the 2 mean, everybody? What does that 2 mean? Oh yeah, for sure, Nina. It's raised to the power of 2, but what does that power actually mean? Yeah, that tells you how many times you're multiplying the x by itself. So everybody, is it fair to say that if I'm looking at x squared, isn't it true that I could also write it as x multiplied by x? Isn't that true? Yeah, okay, cool. Looks like I got the crowd right. There aren't any any pitchforks and torches out here for my head yet, right? Nothing too crazy. I'm not speaking against anything you don't already know. Okay, now let's take a look right over here. Let's take a look at x to the power of 4. Everybody, when I look at x to the power of 4, can you tell me how many x's I should write for that? Yeah, that's going to be 4 x's. You're basically, remember, the exponent tells you how many times you're multiplying this number. So x squared means 2 x's multiplied together. X to the power of 4 means 4 of those x's. So I would write that as x times x times x times x. So before I continue, again, does that all make sense? I'm just asking about knowing that the exponent tells you how many times you're multiplying that variable. Sweet. This class is going to be fun then, because the reason you know that you're supposed to add these right over here, the exponents together, so like 2 plus 4 equals x to the power of 6. The reason I know I can do that is because, remember everybody, by the very definition, that number is telling you how many times the variable is being multiplied. Everybody, how many x's do we see multiplied? Because remember, look, you have the multiplication happening between them. How many x's do we see multiplied together? Yeah, we see 6 of these x's being multiplied together. And so because we have 6 x's being multiplied together, we can shorthand that. Again, talk about it more simply. Instead of saying x times x times x times x times x times x, we can just say x to the power of 6. And that's why you just add the exponents. My party people, does that give you a little more insight or a little better understanding in terms of why that's supposed to happen? Right on. And here we're talking about, we're talking about pure math for math knowledge. This is going to be specifically laws of exponents. Whenever you're multiplying variables or powers with the same variable base, so here it would be x is the same base for both, you can add those exponents because you're saying I have 2 x's and I got 4 x's all being multiplied. So that's a total of 6 x's being multiplied. That's how we can think about it. So let's go ahead and zoom on out. And then we'll go ahead and highlight the second part, the next part of our notes, looking at the quotient of Power's law with the same variable base. So my party people, next up, we're going to write this down. The quotient of powers law, it is going to be the opposite of multiplication. So here, when you are dividing powers with the same variable, you will subtract the exponents. That's what we're going to do there. So feel free to write that down, and then we're going to go through examples right again. Yep, just type got it when you got it. And yes, so that wasn't V, that was Nikita. So Nikita, when you have something like x times y, you would just leave that as x times y. Just like that. If it's x times y, that's just x times y. Nothing to do there because they don't have the same base. All right, a few more moments for those of us writing it down for the quotient of powers law. All right, let's get into it here. Let's zoom on in and let's start boxing. So we're going to subtract the exponents. That's the rule. That's the rule. So if you're just following me blindly, if you're just sitting here saying, cool, subtract the exponents if I see division. Okay, let's just go ahead and do it. And then we'll explain why it actually works. So here, let's say we have something to the effect of x to the power of 5 divided by x to the power of 3. Let's say we have that going on. All right, my party people, first things first, tell me, are these the same base? X up here and x down here, are these the same base? All right, sounds good. And no worries, I'll go back and review once we're through with it. I got you. So we have x to the power of 5 over x to the power of 3, same base with the x. Now let me ask you this follow-up question, everybody. Clearly, we see that it's division, right? A fraction is division. Just want to remind ourselves about that. Yeah, and I know I'm asking you some pretty intuitive questions, but the point of this is, here we go. We're dividing. We know we're supposed to subtract the exponents. So what we know we're supposed to get is supposed to be x to the power of 5 minus 3, which is the same thing as saying x to the power of 2. Let me highlight these values. That way it's a little easier to keep up with. So here we'll have the 5 being highlighted in blue, and then we'll have the 3 highlighted in red. We subtract them, and then we get 2. Again, the top minus the bottom. Again, top minus bottom. There you go. And we have x squared. But before I continue, who here feels 1,000% confident that they know why this works? Who knows why? And it's okay to say you don't know. It's absolutely okay. But you tell me, do you know exactly why we're supposed to subtract when it comes to division? Okay. No worries. No worries at all, everybody. Let me go ahead and ask you all this. If I were to give you something a little different, if I were to say, hey, we have 2 times 7 up top, and then we got 2 times, let's say, 11 in the denominator. Everybody, what's that one thing, that one really, really recognizable thing that we can do when you have the same number in the numerator and denominator being multiplied? What's that word that we can do? Yeah, we can cancel it out. You can cancel them out. So everybody, in this case, isn't it true that I could cancel out the 2 from the numerator and the denominator? Isn't that true? Yeah, absolutely. Absolutely. And that's the idea that we're going to play off of when we are dividing by powers. Watch this. Watch this. Let me rewrite this over here. I'm going to duplicate this over here, and I'll just draw a little line to show the dividing or the separation here. Move you all the way to the side. Everybody help me out. Help me out. X to the power of 5. How many times is x being multiplied if I have a power of 5 on the x? Yeah, it's going to be 5. We have 5 of these x's multiplied. So we'll add 1, 2, 3, 4, and 5. We have 5 of those x's multiplied back to back. Now, help me out, everybody. The 3. x to the power of 3, how many times is that x being multiplied by itself? And to answer that that question that just came in right before I looked away, do we only subtract when we have the same base? Alexa, great question. Yes, only when you have the same base. If I had x to the power of 5 divided by y to the power of 3, nope, just stays the way it is. You can't do anything with it. They're not the same. They're not the same variable, not the same base. Can't do anything with it. But let's show ourselves here. We got x times x again. Everybody, what did we just say? I see x is up top and x is on bottom. What's that C word that we can do again? Yeah, cancel it out. And so with that said, my party people, guess what? I have one of these x's canceled out, another pair of x's canceled out, and a third pair canceled out. How many x's are left, everybody? How many are left? Yeah, there are 2 left, and where? 2 left, and where? On the top. So right there, boom, we have 2 of those x's on top, which makes our final answer x to the power of 2. And that's how we get it. Same deal, right? Same thing. Let me zoom on out enough so you can see both examples. But this is what happens when you just memorize and you memorize the procedure. This is what happens when you truly understand what's going on. So I really want us to make sure that we understand this at the core, because when it's time to practice under a timer, you can get in there, understand that what you're doing is the right way to do it without any hesitation. My party people, is anybody here that was confused earlier understanding a little better now? Awesome. Good. Good. All right. I'm glad it's understandable. Now, I want to show us a couple of different things here as well. So let me first address another example here with quotients, and I'm going to show us what we can do with that. So everybody, let's take a look at this next example. I'm going to zoom on in again, and don't worry, I'll zoom out once I'm done. Let's take a look at this example right over here. Let's now say we have a coefficient, because I know some of us were asking about, hey coach, what if we have a coefficient on the variables? I got your back. So let's say we have 6y to the power of, let's say 7, divided by, let's go ahead and say 4y to the power of 2. My party people, let's go ahead and looking at this here, whoops, excuse me, almost went to the next page. Let's take a look at this here and first address the part that we absolutely know how to do based off of what we've learned so far. Let's focus first on the variables. So everybody, based on those variables, what am I supposed to do with the y to the power of 7 and y to the power of 2? What am I supposed to do with those exponents? Yeah, we're supposed to subtract those exponents. And so y to the power of 7 minus 2, 7 minus 2 is, everybody? Yep, that'll be y to the power of 5. And I'll write that right here up top, y to the power of 5. Now, everybody, are we supposed to do the same thing with the 6 and the 4? Are we supposed to subtract 6 minus 4 to get 2? Is that what we're supposed to do? Yeah, no, we're not supposed to do that. We're not supposed to do that. Everybody, when you have a regular old number divided by another regular old number, what's that one word that we're trying to see that we can do? Yeah, we're trying to simplify. We have 6 on the top and 4 on the bottom. If we were to divide them, that's not an even division. So we can't do that. But we do notice that we can simplify if we wanted to. Everybody, what number are 6 and 4 both divisible by? Yeah, 2. So what I'm going to do is I'm going to divide the numerator by 2, divide the denominator by 2. Once I do that, everybody, we are going to get 6 divided by 2 is 3, 4 divided by 2 is 2. And there's your final answer. 3y to the power of 5 over 2. So with the regular numbers, all I'm saying is simplify the regular numbers, but apply your rules to the variables. Does that make a little more sense, my party people? Simplify numbers where you can, and apply your rules to the variables. And I'll zoom on out one more time before I take you through the last example. So just to go ahead and recap before we continue, when you are multiplying powers with the same variable, you're just going to add those exponents. And it's because the exponent tells you how many times you're multiplying that number anyway. So again, right over here, we're saying we have 2x's with 4x's all being multiplied. That's going to be 6x's lined up. And so we can say x to the power of 6. The shortcut is just add the exponents. If you're multiplying powers of the same base, so the same variable as the base, 2 plus 4, that's 6, and you're done. And that's it. When it comes to quotient, hey, we're going to go ahead and subtract. We're going to do the exact opposite. So we have 5x's up top, 3 on the bottom. 3 of the x's are going to cancel out like we see over here. 5 written up top, 3 on bottom, 3 cancel, leaving you with 2 up top. The shortcut, subtraction. 5 minus 3 leaves you with 2, and there you go. So, again, before I continue, everybody, y'all tell me, have you ever seen problems where the final answer wasn't x squared, but maybe x to the power of -2, or maybe 1 over x squared? Have y'all ever seen something like that? Okay, did y'all ever have any nightmares about that? Yes. Yeah, it could be a little spooker, right? All the time. Well, might need to see somebody for that one. I was hoping maybe sometimes, maybe on a Monday randomly, but I wouldn't expect all the time. But with that said, let me show you what to do when you encounter yourself in that situation. So let's go ahead right over here and look at one more example. So with that, here we go. Oh, 1 second here. I want to shout out. Oh, Lewis. Oh, shout out Secret Lewis. There we go. Hi, everybody. I'm late. Just wanted to give a big shout out to Coach. I really appreciate your help. Took the podcast today and passed. Literally leaving MEPS now. Thank you so much. Proud of you. Right on. Right on, Lewis. Oh, man, that's awesome. So you passed the podcast, so you get to take your verification, I'm assuming, within the next 10 days. So congratulations on passing the podcast. Or if you're telling me that you went to verify it and you just passed, even bigger congratulations. I love seeing that. I love seeing that. If you wouldn't mind, as I always say to everybody who's passed the ASVAB, please do me a favor. Go ahead and reach out to me directly right over here. Because I want to make sure to get your story. You're special. I want to make sure. Oh, you just verified it today? Excellent. Congratulations, Lewis. Let's go. Yeah, if you wouldn't mind shooting me a text, I want to make sure I get your story. That way people that come after you understand that, again, it doesn't take the stars to be aligned for you to succeed. A lot of it is within your control, and I'm glad that you took advantage of every opportunity that was given to you. And also, thank you for being an example for people to follow. I'm happy. I'm smiling coast to coast right now. I got to stay focused on the class, but Lewis, thank you so much for coming in and sharing that. I appreciate you. Let's go. All right, so let's take a look at this third example. Everybody, here's the thing. If you ever see a variable that's negative, let me show you, with a negative exponent, let me show you what to do. So everybody, riddle me this. If I have something like x to the power of 2, in the chat box, let me know. X to the power of 2, that means you are multiplying x by itself how many times? Yeah, 2 times, exactly. Now, riddle me this. If I have x to the power of -2, what does that mean? Crickets. So here's what it means. A positive exponent tells you how many times that variable is being multiplied. A negative exponent tells you how many times the base is being divided. So here, let me go ahead and just separate these to make it a little more clear. So x squared is x times x. X to the power of -2 is saying that you are dividing by x twice, which is the same thing as saying 1 over x squared. So notice how there's parity, there's patterns in math that you can kind of cling on to. There you go. So here again, positive exponents just mean how many times you're multiplying. A negative exponent will tell you how many times that exponent or base is being divided. So x to the power of -2 is just dividing by x squared. My party people, at face value, does that make sense? Yeah, and don't worry, we'll be applying this. We absolutely will. Yeah, and if you want me to explain it another way, I can give you the straight up, just textbook style of what to do. Essentially, here's how I put it. The way that I put it is, you can change the exponent from positive to negative by just swapping it from where it isn't to where it is. Huh? What does that mean? I got you. Don't worry. So here, if you're looking at x to the power of -2, I can change any negative exponent to a positive by just swapping it from the numerator here to the denominator. And vice versa, if I already have something like 1 over, let's say a to the power of -3, well, to make it positive, I would just move it up top. And that is the same thing as saying a cubed, which is the same thing as saying a cubed over 1, but we don't have to write dividing over 1. All I'm saying is, when you see a negative exponent, you can swap it between the numerator and denominator to make it positive. So let me write that down, and y'all tell me if that makes a little more straightforward sense in terms of understanding the rule and then applying it. So negative powers. So negative powers right over here. What you can do, let me make sure that's there. Cool. You can go ahead and swap between numerator and denominator. So let me just move this over here to give myself as much room as possible. So swap between your numerator and denominator to make the exponent positive. So if you're looking for, again, just the rule itself, just to write that down, that's it right there for you, and you're good. But again, we don't need to pay too much attention to that. Today's class is largely going to focus on the product or multiplication rule, the quotient or division rule, and then the power of powers rule. Yeah, it's Deja, I got you. And let me know if I'm pronouncing your name correctly. I got you. So with that, let's go ahead here and bring it on down, and let's take a look at power of powers. Again, cue the lightning and thunder. So this one's not going to be as bad as you might think. That sounds good to Deja, thank you. So this one's not going to be as bad as you might think. And to prove that, let me go ahead and show you what something of this nature might look like. Let me make a new page, and let me zoom on in. All right, so let's take a look here. Let's say we have something like this, everybody. Let's say we have x to the power of 3 squared. Whoa, what's going on there? What's going on there? Everybody, what do y'all think this is going to be? X to the power of what? What do you think this is going to be? X to the power of what? I see some people saying 5, some people saying 6, some people saying 9. Which one is it going to be? Some more 5s, 6s, 5s, 9s. Oh man, there's an argument. All right, so let's go ahead and understand. So here's the rule. When you have powers to a power, so here we have a power to a power, notice how this is very different from x cubed times x squared. If it were like this, then yeah, we would just go ahead and add, because you have 3 of these x's and 2 of these x's being multiplied. So you have a total of 5 being multiplied. 3 plus 2, that's going to be x to the power 5. My party people, does this first part make sense? Again, if we had x cubed times x squared, yeah, we would go ahead and add those up and we're good. Sweet. So when we have this powers to powers, so let me just write this here. Powers to powers. Well, what you're supposed to do is multiply. Let me fix that arrow. We're supposed to multiply. And so the straight up rule, multiplication, 3 times 2 is 6. But my party people, who here feels like they actually understand why we multiply? Who here actually feels like we know why? Okay, a couple handful of folks from the beginning, but there's a lot of silence from the rest of us. And don't worry, again, that's what I'm here for. You know I got your back. So, and again, yeah, thank you for being honest. If you're not sure, yeah, be honest. So, here's why we're supposed to multiply when you have a power to a power. My party people, help me out. When I'm taking a look at x cubed all to the power of 2, everybody, what does it mean? What does it mean? Let me actually just draw this box over here. And then let me fill it in with a different color. Yeah, red's fine. Okay, so let's say we have this, right? I just put a red square in front of that. Everybody, if I have this red square to the power of 2, what am I doing with this square? Right, I'm multiplying it by itself how many times? Twice. Exactly. So what's going to happen is we're going to have the box multiplied by the box. That's exactly what's going to happen. So what do we do here? Well, guess what? If we remove that box, we know that that's x cubed. We see it right there, x cubed. So if we were to go and say, hey, x cubed times x cubed, everybody, guess what happens? What do we do here? When you have x cubed times x cubed, what does that turn into? Yeah, we're supposed to add those exponents. 3 plus 3 gives you x to the power of 6. Huh, look at that. Pretty interesting when you think about it, how exponents are supposed to be thought about. Yeah, you see that the product rule applies and you just have x cubed shown twice. So that's why you multiply to just get x to the power of 6. And if you don't believe me on that one, I'm going to give you another example right here, side by side. Let me give you a different example with a number other than 2. Let's go ahead and say we have over here, let's say we'll do y to the power of 3 all to the power of 4. My party people, watch this. No, power to powers, Rosalie. Rosalie, powers to a power, you multiply the exponents. So that's what we did here. We multiplied the 3 and the 2 together to get 6. That's the shortcut way. The way it actually works when you actually break it down is, hey, anything squared is just whatever this is times itself, because squared means multiply this by itself twice. Boom, boom. And now we see that the product rule applies, and so we add those exponents, giving us 6. Let me show you a little better right over here. We have x to the power of 3 all to the power of 4. I'll do the same thing. Everybody, this 4 right here on the outside tells us we're going to multiply whatever this is by itself how many times? This exponent here tells us we're going to multiply this by itself how many times? Yeah, 4 times. So allow me to grab this, duplicate it once, twice, 3 times, and one more, 4 right there. That's what this means, my party people. This 4 tells us we're going to write it 1, 2, 3, 4 times. Everybody, take a look. Isn't it clear now that the product rule applies? We have all the same variable bases. Now we're going to add all of these exponents. 3 plus itself 4 times, that's 12. That's multiplication. Repeated addition is just multiplication. And so this is going to give us y to the power of 3 plus 3 plus 3 plus 3, which is the same thing as y to the power of 3 times 4. It's the same thing. 3 times 4 right there. And that's how we get y to the power of 12. So we can go the shortcut method, immediately multiply those exponents. But if you have that essential understanding, that fundamental understanding, you'll know why you're doing what you're doing, and that confidence is going to skyrocket so much faster. My party people, am I speaking crazy gibberish, rocket science nonsense, or is this somewhat understandable to you where things are right now? Y'all tell me. Alexa, I love you. Both. Right on. And so we'll get the chance to practice as we go along here. I got y'all. Cool. Sounds good. So going back to this one here, the reason this is not x to the power of 5 one more time, my party people, is because the exponent right there, that 2, by nature is going to tell us, hey, this right here, this x to the power of 3, multiply it by itself twice. And that's what this looks like. X cubed times x cubed. This is where we apply the product rule, the multiplication rule, because we'll now add those exponents and we get 6. So in short, 3 times 2 is 6. We can show it like this, but the shortcut that we'll be taking looks like that. Going back over here, for those of us asking, hey coach, why is this not y to the power of 7? Well, it would be if it was written like this. Y to the power of 3 multiplied by y to the power of 4. If it was written like that, then it would be y to the power of 7. Absolutely. Because you have the same base, you multiply, so you add those exponents. There you go. This is different though. This is different because here you're saying y to the power of 3 all to the power of 4. So this whole thing to the power of 4. So what that shows us to do, that tells us to do, is, hey, whatever this is right here, multiply it by itself 4 times. Y cubed, y cubed, y cubed, y cubed. And once you see all that lined up, just like we did over here, add those exponents, 3, 6, 9, 12, and there you go. So the shortcut rule is just when you see a power to a power, so an exponent raised to another exponent, you just multiply those exponents together. Nice and easy. So you can skip all of this and just get straight to the answer. And yeah, Jessica, this is going to be Math Knowledge, Unit 11. Let me know if that makes sense. Yeah, and the recording will be available first thing tomorrow. So, my party people, let me know in the chat box. Let me know if this gives us, again, a little bit of better understanding. We have one more tiny thing to go through that takes literally 20 seconds, 25 seconds, and we're done. Awesome. So before I move back, take a chance here, take a screenshot. I'll give you 10 seconds. All right. 3, 2, and there's nothing else. That's just the part that I made a new screen for. But here is where we were with everything else. So let me just go through this one last bit right down here. So everybody, if we don't see an exponent, what's the exponent always going to be? Help me out. Yeah, if we don't see an exponent, the exponent is always 1. So for example, you know how some of us might not totally get why, hey, x times x equals x squared? You know, sometimes it may be confusing as to where those numbers came from, right? Or understanding how x times x cubed equals x to the power of 4. Well, my party people, that's because, remember, the exponent tells you how many times that number is being multiplied. So technically speaking, let's take a look down here first. Technically speaking, this is x to the power of 1 times x to the power of 1, because it's literally just one of those x's sitting there being multiplied. And so X times X, that's 1 plus 1, giving you 2. Same thing up top over here. If we have X times X to the power of 3, again, this is 1X. This is one of these X's multiplied with 3 more X's, and that's why we get 4 of those X's, or X to the power of 4. Does that make a little more sense there, everybody? When you don't have an exponent listed, we should know that it's automatically 1, and then we get at it. And so, yeah, the question, the person who asked about, hey, when will it be 2x? I got you, Nina. Nina, that's going to be when you have x plus x. X plus x is the same thing as double x, because you have 2 of them. So that's double or times 2. That's different than x times x, because x times x is x squared, because you have 2 of them being multiplied together, not 2 of them being added together. There's a difference there. So hopefully that gives us a little more understanding. Perfect. I got you, Nina. I'm glad you asked the question, because there's always somebody else that has the same question. And I hope I can serve you and that person at the same time. But with that, I think we're ready. I think we're ready to practice. I think we're ready to get thrown to the wolves to see how far we can go. So with that, shout out Nikita for showing that thankfulness to Nina. Right on. Let's go ahead here and move forward. I'll give you all 15 seconds to take any final notes or screenshots if you'd like to. But when you're ready, type "got it" in the chat box, and we're going to get into our time practice. Right on. Let me go ahead and get this timer up. We'll set it up to start off with 2 minutes. There we go. All right, let's go ahead and move it on forward here. All right, so obviously we're doing word problems today, so ignore this part. Right over here, we're doing math knowledge practice, so we're going to take 1.5 minutes per question, all right? 1.5 minutes per question. That's actually closer to the time that you'll get on the math knowledge. On the math knowledge, it'll be about 1 minute and 16 seconds per question. So I'm giving you a little more time than you would expect, but I promise you, the math knowledge, the great thing about it is that it's pure math. You either know it and you know what to do, or you don't and you're gonna guess. That's a lot better than word problems where you might be reading it over and over and over and over again, hoping something starts to make sense. The great thing about math knowledge, again, is once you know it, you know it. So here we go, my party people. Let me put the timer on the screen and let's start the fun. Let's start the fun right over here. There it is. There's the timer. 3, 2, and 1. My party people, just type "ready" in the chat box when you have an answer. Don't reveal it. You got this. I love y'all. That's funny. All right, my party people, and that is time. Let's go ahead, put those answers in if you got one. If you are going to be taking a guess, put a question mark next to your answer if it's a guess. It's all good. It is all good. All right, let me go ahead and take the timer off and let's get started here. Let's understand what's going on. So again, we can make good decisions, raise that confidence, raise that score. Here we go. So the problem tells us to simplify the following expression. Notice that we have a lot more going on than we did in the beginning. Remember how I told you, we're not just trying to do those regular rinky-dink, just x to the power of 5 times x squared. We're going to have much more to do. So, my party people, let me show you what we're supposed to do here. First, let me ask you this. Everybody, is there anything outside of this parentheses here or outside of this parentheses here? Is there anything outside of them, like telling us to do anything? No, right? There's nothing stopping us from just saying, hey, look, if we have parentheses 3x to the power of 5y to the power of 3, if we just have that and wrap it into parentheses, well, guess what? There's nothing stopping us from just taking that parentheses away. There's nothing stopping us. The parentheses is just there to kind of just show you the groups, but there's nothing in this situation stopping us from just writing it all out. So why does that give us an advantage? Well, the advantage that we have is understanding that when you're just multiplying a bunch of things together, you can multiply in any order that you want. Let me prove the point to you, everybody. Let's do something ridiculously hard. And you know me, this is going to be impossible. Let's say we have 2 times 3 times 4. Again, like I said, something ridiculous, something hard. Everybody help me out. What is 2 times 3? Chat box, hit me up. 2 times 3 is going to be 6. Thank y'all. Perfect. And then 6 multiplied by 4 is going to give us, 24. So cool. All right, great. What if I switch the order up, though? What if I swap the order to not 2 times 3 times 4, but what if I did the 4 first? 4 times 2 times 3. What is that going to be? Let's see. Everybody, 4 times 2 is going to be what? Yeah, it's going to be 8. 8 times 3 is going to give us what? 24. Look at that. So notice, it's the same thing. When you are multiplying a bunch of values together, you can multiply in whatever order you want. For those of you who may remember this, this is called the commutative property of multiplication. I hate sounding technical, but that's what that's called. Anybody here recognize that? Commutative property? A bunch of no's. Oh no. Shout out to the couple of folks who said yes. Never heard of it? Well, here you go. So let's go ahead and take a look here. So what we've done so far is just take away those parentheses because there's really nothing stopping us. Nothing, no exponent here, no nothing. So we're good. Now we understand that we can multiply in whatever order we want to. Why is that helpful? Because we're going to multiply in the order that we need to. Everybody, we have these regular old numbers, the 3 and the 2. We can just multiply those together. Everybody, what's 3 times 2? Yep, that's going to be 6. So we have 6 right there. Next up, let's just focus on what we can multiply. Everybody, can I multiply the x to the power of 5 and the y to the power of 3? Can I apply the rules that I learned to that? Oh, no. Well, why not? Why can't I do that? Why can't I do that? Right, because the bases are not the same. This is x, this is y. These bases are not the same. We need the same variable. So instead of highlighting the x and the y, I am going to highlight the x to the power of 5 and the x to the power of 2. Those two I can absolutely go ahead and bring together. Everybody, if I'm multiplying x to the power of 5 and multiplying with x to the power of 2, what am I supposed to do specifically? Add what? Again, specifically. Add the exponents. Appreciate you, V. Yep. Yeah, add those exponents. So we are going to have x to the power of 5 plus 2. And I'll write that on the side over here. That's going to be x to the power of 5 plus 2, giving us x to the power of 7. So I'll write that right there. And then from here, my party people, we have lastly y to the power of 3 with the y to the power of 4. Everybody, what is y to the power of 3 multiplied by y to the power of 4? Yeah, so we can write that out as well. That's going to be y to the power of 3 plus 4 because we're doing the product property where we add the exponents. And that's going to give us y to the power of 7. Booyah, and there we go. That's why the correct answer to this question, my party people, is going to be B. 6x to the power of 7, y to the power of 7. And there we go. So how do we feel about this first one? Let's talk. Let's reflect. Who here, even if you made a mistake, even if you were confused or you took a guess, do you feel like you understand the mistake you made or you understand what you can do next time? Oh, actually kind of easy. You feel like you understand it now and you got it. You felt great about it the moment you saw it. I love it. I love it. Let's go. So why 6 and not 5? Yeah, great question. So remember, multiplying regular numbers, we're just going to multiply regular numbers. We're still doing that with the variables too, but you're just taking shortcuts with the variable technically. So for example, like 3 times 2, we can multiply them because you're just multiplying numbers. You're going to get 6. When you multiply x times x, I don't know that that's going to be 9. I don't know that that's going to be 25. I don't know that that's going to be anything. I don't know anything at all. All I can say is that I'm looking at a variable times another variable, and another way to write that, just like I write 5 times 5, you can write it as 5 squared. X times x, I can write that as x squared. My party people, does that make a little more sense now too? Because the 5 squared, I can write that as 25 because I know what 5 squared is. But when you have a variable, well, there's only so much you can do. And in this case, we don't want to read it as x to the power of 5 times x squared. No, we can simplify it a little bit. We can just write x to the power of 7. Right on, everybody. So with that said, who here feels like they got the jitters out of the way and they're ready to try the next one out? Yeah, all right, sounds good, everybody. Let me go ahead and get that timer right back up. And also just want to do a quick probe. My party people, has the stream so far in this class been pretty crisp and clear? Oh, awesome, perfect. Yeah, I changed a lot about my setup here. I'm very thankful that this works because the recordings, again, that quality is going to go up. So I appreciate y'all for being patient with me on that. Let's go ahead and get to this next one here. 3, 2, 1, let's go. And that is time, my party people. Go ahead, put those answers in. What do you have? What do you have? And again, if you're taking a guess, no shame. No shame at all. Put a question mark next to your answer if it's a guess. Because remember, on the actual test, hey, anybody can get lucky. So take the points where you can. Give an answer no matter what. All right, my party people, let's go ahead and get this one in. Let's see what we got. Let's get the timer out of the way. Right over there. Perfect. All right, here we go. Simplify the expression. We have 4a cubed times b squared times c to the power of 4. All of that multiplied by 5a squared, b5, c nothing. Okay, so a couple of things that we have to address, but I think we just need to really address one thing that's kind of weird that we haven't seen yet. But besides that, I think we're good. So first things first, everybody. Is there anything stopping us from just taking out these parentheses? Is there anything stopping us? Yeah, nothing at all. There's no exponent here stopping us. We're good. So what we're going to do is just write it out again without the parentheses. And if you want to, you can actually just do it like this. I'm going to write out the numbers multiplied in front of each other. So we have 4 times 5. Then I'll go ahead and write out each variable pair together. So we'll have, let me actually change this to be a little smaller. There we go. So we have a to the power of 3 multiplied by a squared. Then we have b squared and b to the power of 5. So that'll be b squared times b to the power of 5. And then one more here in purple, we're going to have c to the power of 4 and just c. And that's probably going to be the most confusing part about this problem. But I'll show you that it's really not that confusing at all. Let's work one step at a time. With these regular numbers here, 4 times 5, what's that going to be, everybody? Yeah, 4 times 5, that's going to give us 20 right there. Booyah. And then when we take a look at a to the power of 3 times a to the power of 2, what will that be, my party people? 5? Yeah, a to the power of 5. Yeah. Spanish. Someone said quinco? How do you say that in Spanish? Al poder de cinco. Yep, right there. A to the power of 5. And then we'll say b over here, b squared times b to the power of 5. I'm absolutely joking with you guys. I'm Dominican. I speak Spanish. I'm messing with you. So with that, we have b squared times b to the power of 5. And that's going to give us b to the power of 7. There you go. b7. And here's that weird part that we have to address. We have c to the power of 4 multiplied by c. Looks like I got some cousins in the room. Welcome in, everybody. All right, so here we go. c4 times c. When we take a look at this, everybody, what's going on with this one here? Because I don't see an exponent, but what's that exponent supposed to be? Yeah, the exponent there is supposed to be 1. So there we go. We'll write that right there up top. Boom. And yep, exactly. If you don't see the exponent, it's always 1. So allow my screen just a moment here to go ahead and reflect upon that. Give me one moment, everybody. It looks like it's just taking a moment. All right, so continuing where we left off, my party people. Thanks for the patience on the interruption. But here we go. We have c to the power of 4 multiplied by c to the power of 1. So with that said, everybody, now that we know that there's a 1 there for that exponent, we have 4 plus 1, because we have 4 of these c's multiplied by another 1, so that makes it 5 c's. 5 c's multiplied together is c to the power of 5. So here's our final answer. It's going to be 20 a to the power of 5 times b to the power of 7 times c to the power of 5. Everybody, the correct answer is going to be which one? Yeah, that's going to be D. That is our correct answer. And boom, there we go. Yeah, I see some nice excitement there from those of us that got it correct. Yeah, let's go. That's what I'm talking about, everybody. Remember, the success that you're going to obtain, again, before you actually learn and get it done, it's going to feel foreign to you. But you have to give yourself the opportunity and the patience and the grace to work through the mistakes. That's what it's going to be. That's what it's going to take. And so I'm really proud of you guys for putting yourself first, even when it's hard. Thank you. Thank you for putting up with this. So with that, I just did a quick Google search. It looks like after an hour, that's what happened with the stream that I'm using. It just fizzles out after an hour. Just had to reset it real quick. So thanks for being patient on that as well. Who's ready for the next question? Awesome. Cool. So let's go ahead and get that timer right back up. Here we go. And 3, 2, 1. Next problem. And go. And that is time. My party people, go ahead. Put those answers in. Put those answers in. Yeah, put a question mark next to that answer if it is a guess. Again, no shame. No shame in taking a guess. So let's get the timer out of the way. Let's dive on in. You know the routine. Let's get it done. So zooming on in. Here we go. So we have 2m to the power of 4, n to the 6th, p to the power of 2, and then we have these over here. Like we said before, everybody, are we good to get rid of the parentheses immediately? Yeah, we're good to get rid of those parentheses immediately because there's nothing in the way. So now let's go ahead and show ourselves each step. Here we're going to be multiplying, as we see right there. That's multiplication. So we have 2 multiplied by 3. Everybody, 2 times 3 is 6. Exactly. That's going to start us off right there, immediately telling us that C is not going to be the correct answer because of that 5. Not going to be it. Next up, let's take care of the same letters, the same variables. We have m to the power of 4, m to the power of 3, no other m's in place. Everybody, m to the power of 4 multiplied by m to the power of 3 gives us m, to the power of 7. Look at that. There we go. Next up, keeping it going smooth. Here we go. We have n to the power of 6, n to the power of 2, n to the power of 6 times n to the power of 2. Yep, add those exponents. Gives us n to the power of 8. And then lastly, let's take care of it. We have p squared and p to the power of 5. Multiply those by adding those exponents, and that's going to give you p to the power of 7. And there we are. So based off of all this, we don't have a 7 on B's M, so that's going to be gone as well. And we don't have the 8 on the 6 there, which means the only correct answer that can be is D. Booyah. And there you go. And you should feel smart. I saw you. I saw that comment before it slipped through. You should feel smart. Remember, everything is difficult until it's not. Everything is difficult until you do it for the first, second, third, fourth, fifth time. So remember, be impressed with how adaptable you are, because you're going to be doing a lot of adapting in the service. A lot. So give yourself credit where it's due. You're a lot smarter than you think you are. Here we go, my party people. Let's get to the next one. Y'all ready? Right on. Better be. Here we go. 3, 2, and 1. Next up. Oh no, something new. How will you respond? Get it done. And that is time. My party people, go ahead, put those answers in, put a question mark next to your answer if it is a guess. All right. Sounds good. Let's get it going, my party people. Let's zoom on in and let's see what we got. So the goal here is to simplify the expression that they give us. And so again, an expression is just a mathematical statement right there. So cool. We have x to the power of 8, y to the power of 6. Pop quiz question, everybody. Can I multiply these two together right here to get xy to the power of 16? Should I do that? Yeah, absolutely not, everybody. Absolutely not. But the follow-up question, why is it that we can't do that? Why not? Why not? Why can't we multiply these two together again? Because they don't have the same what? Base. Exactly. They don't have the same base. This is x, that's y. They're not the same. They are not the same. But when we take a look at the entirety of the expression, we're going to see that we have an x in the numerator, an x in the denominator, y in the numerator, and a y in the denominator. So it looks like this changes from the product property that we've been applying to the quotient or the division property of powers. When you divide powers, remind me, everybody, we do what with those exponents of the same base? Yeah, exactly. We subtract and we are good. So here, let's focus on one at a time. So first, we'll go ahead and look at the x's. So x to the power of 8 multiplied by, or divided by x to the power of 3. Let me draw our line. This will end up being 8 minus 3, which is 5. So we'll write this as x to the power of 5 up top. Again, x8, x3, that's going to be x to the power of 8 minus 3, which is x to the power of 5. And that's what's going to give us the 5 up top. Because it's a positive 5, we'll put it up top. If it was a negative, we could leave it as a negative up top or put it as a positive in the denominator. Hint, hint, we might be dealing with a problem like that soon. So next up, let's take a look at the y. We have y to the power of 6, y squared on the bottom. We will subtract, and that will be y to the power of 4. Since there's nothing in the denominator, we can just write the 1, or we can just say x to the power of 5, y to the power of 4, making our answer D. Look at that. So who here really does truly feel like, hey, if we saw questions about exponents on the math knowledge, I would probably get it right? Yeah, like, and some of y'all are asking, like, is this how tough it gets? Yeah. You can take maybe a tiny fraction of a step up in terms of how complicated it can be, and I'm sure we'll touch on that in today's class. But notice how no matter what we've seen, there are rules that we can follow to get the job done. And that's what it's all about. That's what math knowledge is literally all about. Do you know your rules of mathematics, and can you apply them to pure mathematics problems? That's really what it is. So let's go ahead and stop wasting time, because you know I like talking. Let's go ahead and get into the next one here. 3, 2, and 1. Let's go. All right, final 2, 1, in time. My party people, go ahead. Put those answers in. What do we have? All right, looks like we've had D for a couple of questions now in a row, but don't let that inflate your ego. Don't let that get you overconfident, because at any point, you could be thinking that the next answer is going to have to be the same thing, and then we get got. So don't worry about what answer choice it is, and worry more about if you understand why you are right or why you are wrong. So here we go. A to the power of 12 over A to the power of 5. That right there, that'll give us A to the power of 7 up top because we're subtracting. And then over here with B to the power of 9 and B to the power of 7, that's going to give us B to the power of 2. And that'll stay up top. And there we go. And that'll just be it. A to the power of 7 times B to the power of 2. My party people, are we good on this one? Do we understand why it's the positive version and not the negative version? Yeah, the way that it would be C is if it were the opposite way. If it was A to the power of 5 times B to the power of 7 over A to the power of 12 times B to the power of 9. If it were like this, everybody, then when we subtracted, again, it would be 5 minus 12, not 12 minus 5. So that would give you A to the power of negative 7. And again, 7 minus 9, not 9 minus 7. 7 minus 9 would be B to the power of negative 2. So you could write it like that if you wanted to, or you could write it as 1 over A to the power of 7, B to the power of 2. Because remember, if you have a negative exponent, you can turn it into a positive exponent by throwing it where it's not. If it's up top, throw it on the bottom. If it's on the bottom, throw it up top. If you want to change the sign on the exponent. Oh yeah, and also great question. So Alexa's question, and this is for everybody here and the recording as well. Alexa's question was, how do we know which number or letter goes first? And yeah, it's going to be, just like Vana said, in alphabetical order. And the reason is because, well, it's just formalities. It's just formalities with mathematics. You can absolutely still be correct if you said, B squared times A to the power of 7. That's still correct. But in terms of speaking simplistically and in a way that everybody can agree upon, the math community said, hey, when you're using variables, just do it in alphabetical order. And that's it. And everybody agreed, and we're good. Yeah, exactly. So, Alexa, it's not anything that you should be like, oh, why is that the case? No, it's just one of those things. Yeah, we agreed upon it. And that's it. All right, let's go ahead and dive into the next one here, everybody. 3, 2, and 1. Keep up the great work, everybody. And that is time. My party people, go ahead. Put those answers in. Put those answers in. What do you have? Right on, right on. All right. Looks like we have a consensus on what we believe the answer is. Sounds good. Let's go ahead and get it done. So simplify the following expression. We have another quotient of powers rule. We have m and m over here, 15 and 6. We know that when we are dividing powers, we subtract those exponents. So that's going to give us m to the power of 9, because 15 minus 6 is positive 9. And then 7 minus 4 for the ends. That will be n to the power of 3. 7 minus 4 being 3. So we have m to the power of 9, n to the power of 3, making A the correct answer. And there we go, my party people. Are we good on this one? Any questions before we move forward to the next one? Sweet. No questions. All good? All right. Here we go. We're going to keep it moving. And don't worry, we are going to get even more exciting because we just hit our quotient of powers rule. So let's see what happens when we get into perhaps something else. And looking at our final 2, 1, and time. What are those answers going to be? That was hilarious. C for see you later. C for catch me outside. All right. Sounds good. I'm glad that we're having fun. It shows that the level of the math that we're doing right now feels relatively easier than it did before. And that's a good thing. That's a really, really good thing that we're able to have fun like this. So I'm glad for y'all. So here we go. Simplify the following expression. We have x to the power of 5 to the power of 3. So when we deal with that, remember there are 2 ways to think about it. The first way is just knowing the shortcut rule. When you have a power to a power, we multiply those powers. So this ends up being x to the power of 5 times 3. And everybody, 5 times 3, that's going to be what? Yeah, that's going to be 15. So that's going to give us x to the power of 15. That's one way to think about it. The other way that we can think about it would end up being something like this. We could have, hey, we have anything. If we have anything to the power of 3, well, that's going to be that anything multiplied by itself 3 times. And we know what that anything is inside that box. It's x to the power of 5. So this makes it x to the power of 5 multiplied by itself 3 times. And so when we see it like this, what do we know we're supposed to do with those exponents, everybody? When we see it specifically like this? Yeah, it's going to be the product rule that we're applying because we're multiplying these powers. So we will add the exponents. And so that would be 5 plus 5 plus 5, which is 5 times 3 anyway, x to the power of 15, giving us C as the proper answer. And there we go. I will catch you outside. Yeah, so Joseph, if you had x to the power of 5 to the power of 5, that would end up being x to the power of 25. Or if it was literally just 5 to the power of 5, that's 5 times 5 times 5 times 5 times 5. So written out 5 times. So hopefully I answered your question because I was trying to interpret which way you were going with that. So let me know if that was the case for you. But with that, looks like we are set to continue on. Let's see how far we are until we get to the craziness. We are at 7:33. I believe we can go ahead and take a step forward here, my party people who would like to get into some problems that may look a little unorthodox. All right, sounds good. We'll skip ahead a little bit. So let's go ahead and really feel that torture. I mean, fun. Again, fun, fun, fun. So here we go. 3, 2, and 1. Let's go. There it is. Timer has started. And that is time, my party people. Go ahead, put those answers in, put those answers in. Looks like we got some A's, some B's, mostly B's. Joseph was saying B for yesterday was my birthday. I don't have an option Y out here. I'm kidding. Happy belated birthday, Joseph. I'm glad you're here today. All right, let's go and have some fun here. So time's up. Let's get it done. Here we go. So this looks a little weird, right? This looks a little weird for sure because we just haven't seen it in this configuration yet and being set up this way. But my party people, what do we know about the order of operations, about the order in which we should operate? How do we kind of navigate this? Yeah, parentheses first. Let's go ahead and focus on one thing at a time. Let me go ahead and write this again over here. So we'll have x to the power of 5 multiplied by x to the power of 4. And then in another parentheses over here, we have x cubed, and all of that will be squared. Okay, so first things first, we're going to take care of the parentheses. But before I take care of this here, my party people, will you let me know, does this exponent of 2, does it apply to the x cubed, or does it apply to all of this over here? Let's be sure. Let's be sure about this. Does it apply to the x cubed, or does it apply to everything? Yeah, just the x cubed. Notice where it's at. The 2 is an exponent. Let me zoom on in a little more. The 2 is an exponent right over here on this parentheses. So with that said, everybody, we can take care of this first. Let me just highlight this over here. We'll take care of that first. Everybody, x to the power of 5 times x to the power of 4 will be what? Yeah, x to the power of 9. So there we go. We have that, my party people. And then we still have the x to the power of 3 to the power of 2. Okay, so before we multiply these two together, what must I do, everybody? Oh, y'all already wrote the answer out for that one. Exactly. We have to take care of this here. We got to take care of the exponent, so a power to a power. And so we know that we're supposed to multiply, so everybody, that x cubed squared turns into x to the power of what? Yeah, we're going to multiply those powers, so that's going to be 3 times 2. Yeah, giving us that 6. So that'll be x to the power of 9 times x to the power of 6. Okay, we just took 2 steps here. We're still going. But what do we do here now? Now we're multiplying x to the power of 9 times x to the power of 6. What do we do there? Yeah, add those exponents, and that's what's going to land us at x to the power of 15. And there we go. How do we do on this one, everybody? How do we do on this first one that was actually truly a mixture of these rules? Feeling perfect, feeling great. You like the challenge. Right on. Once you thought about it, it became easy, right? Once you realized, hey, look, it's just a procedure. It's just a procedure. And if I know my rules, I'm in a great position. And so that's what we have to look forward to. So let's get ready. Let's get the timer up and let's get the next one done. 3, 2, and 1. Keep it going. How do you do this one? And looking at our final 3, 2, and 1. Go ahead, put those answers in, everybody. Put those answers in. What do we have? What do we have? All right, D for daisies. All right, sounds good. So even if we're feeling a little confused about this one, let's go and check things out here. So let's simplify this. So first things first, everybody, what do we notice? What do we notice? What rules do you think that we're going to be applying here? The product rule, quotient rule, power of powers, negatives. How do you feel we're supposed to, what do you think we're supposed to be applying here? Which ones? Quotient and power of powers, V. The subtraction one, which is quotients. Power of powers and quotients. Okay, cool. So it looks like we have that understanding. Okay, sounds good. So let's check it out. Grand question is, well, which way are we supposed to go first? Do we take care of the quotient first or the power of powers? Yes. Yeah, we can actually, so here's the answer to that question. The answer to this question is you can do either. You can do either. And let me show you how that'll work to make sure you do it the right way. So here we go. Let's look at the parentheses. If we know, if we're going to do it the normal way that we know by following PEMDAS or the order of operations, we know that we take care of the inside of the parentheses first. So that's specifically going to be y to the power of 8 divided by y to the power of 3. Everybody, if we simplify this, if we apply our quotient law, what do we get when we divide y to the power of 8 by y to the power of 3? What do we get? Yeah, we're going to get y to the power of 5 because we're going to be subtracting those exponents, giving us y to the power of 5. There we go. Now we are not going to forget to write that 4 right there. Let me just remind myself about where that is. Actually, let me do myself a favor. Let's just write that in purple. All right, great. Now from here, my party people, now we have that power of powers rule to multiply, right? Multiply those powers, multiply those exponents, and we are set. So once we do that, 5 times 4, that's going to give us y to the power of 20. And there we go. And that's how we get D as the answer. But again, I want to show you how to do it in more than just one way so you're well equipped for the future. Let me show you the other way that we can do it. So if you wanted to apply your power of powers rule first, here's what that'll look like. So we have y to the power of 8, y to the power of 3, all to the power of 4. Okay, so here's the thing about, again, specifically with powers. Notice that this is not like polynomials. Notice that this is not like y plus 2 or y plus 8. No, it's y to the power of 8 divided by y to the power of 3. It's literally one giant term, right? So the way that you're going to handle this, if you wanted to do the power first, you would go ahead and make sure that you multiply every power by 4. Every power on every term. Again, this is one big old term. This isn't like y plus 2 squared. That's very, very different, everybody. That is very different. So I want to make sure nobody gets confused or believes that they should be applying something that is actually not the case. So let me just show you what would happen here. When we apply the power of powers law first, here we go. Help me out, everybody. We have y to the power of 8 to the power of 4. Multiply those powers. 8 times 4 is... 8 times 4, yeah, that's right, gives us 32. So we have y to the power of 32. Next up, though, let's check out the y to the power of 3 to the power of 4. What's that going to be? 3 times 4, that's going to give us, exactly, that'll give us 12. So we have y to the power of 12 in the denominator. Everybody help me out. Now let's apply that quotient law. 32 minus 12 gives us, 20. And so we see that we can get the same exact answer. We can apply one rule first, so long as there's nothing in the way of it happening. So when you have a power to a power, you multiply all exponents by that power. But remember, it is very different than polynomial distribution. It is not the same thing as saying x plus 8 squared. Very, very, very different. All right. This is all technically over here, technically just one term. All right. So my part, that's funny. In Anderson, we trust. That's Coach Anderson. I'm kidding. I'm not like that. You're good. So there we go, my party people. Are we set to try one more out? All right. Sounds good. Let's go ahead and have some fun here. Let's take a look at the next one. The next one I will give us, here we go. 3, or let me get the timer back up first. Here we go. There's the timer. All right, here we go. 3, 2, and 1. And time is up, my party people. Go ahead, put those answers in. Put those answers in. What do we have? What do we have? Tried to catch you with this one, huh? Okay. Well, let's see if you got, my friend. Here we go. So, in this one here, my party people, when we take a look, let me just get the timer out of the way. All right, so let's go ahead and give it a shot here. So, we have a parentheses here and a parentheses here. So, let's just take care of each parentheses one at a time. So, everybody, when we take a look at the z to the power of 7 and z squared, that's absolutely going to be z to the power of 5, right? Absolutely. Or is that going to be z to the power of 9? Yeah, that's going to be 5. I know some of us are very used to seeing anything that's next to each other as multiplication, but notice that this explicitly shows division. Explicitly shows division. So we have z to the power of 7 divided by z squared. We have the same variable. So 7 minus 2, that's going to be 5. Now when we take a look at this next one, here we have z to the power of 4 times z to the power of 3. So we are going to add those exponents, and that's going to give us z to the power of 7 for this one. So we'll have z to the power of 7. And then once we have these two together, we multiply. Z to the power of 5 times z to the power of 7 equals z to the power of 12. Exactly. So really quick, let me go back because I saw a couple of questions about this right here. How did we get z to the power of 5, coach? I got you. Well, take a look right here. This is z to the power of 7 divided by z to the power of 2. That's the same thing as saying z to the power of 7 divided by z to the power of 2. It's the same thing. And so when we take a look at that, that's the quotient rule. We are subtracting those exponents, and then we get z to the power of 5. So, Eddie Reese, let me know if that makes a little more sense for you. I got your back.